This brings us to the Flash poster session, and we already have our presenters aligned. For this, I will invite Sanyal, the project leader of the Hybrid Systems Group in National Renewable Energy Laboratory, NREL in the US. The floor is yours for moderation.
Good morning. Guten Morgen. I'm trying. Namaste. I'm just honored and delighted to moderate this session. We have 25 poster speakers who will be coming on stage here and we'll have 30 seconds to share a little bit about their poster, which is a pitch session for you to go see their poster. The poster session is this evening. It is combined with a reception, so we hope you'll be there. Reception is the incentive. There will be cards available where you can vote for these posters, and there'll be 2 awards that will be given out during the closing remarks tomorrow. So with that, I would like to address the poster presenters directly. I am 100% sure I am going to mispronounce your names, so my apologies. I know what it is like to be there. I will try my best. So with that, I am going to name the institutions when I call on the presenters, but we have 2 slides that lists all the institutions that have posters here. And with that, I would like to invite our first presenter, Lisa Gaedke-Merzhäuser, who will present her pitch on high-performance computing meets approximate Bayesian inference.
Hi, everyone. Thank you. So we were wondering about how we can make Bayesian inference and spatial temporal modeling in particular more scalable, because it's often limited by long run times. And in particular, we look at a solution method that's called integrated nested Laplace approximations, which is based on sparse Gaussian Markov random fields. And we develop GPU-accelerated block solvers for the computational core operations, which are Cholesky decomposition and selected matrix inversion, and put forward a distributed memory parallel scheme. So if you're interested in Bayesian modeling or in linear solvers, for sparse matrices with recurring sparsity patterns, please swing by. And if you're interested in neither of those, you're still welcome to swing by.
Our next presenter is Johannes Gebert from the University of Stuttgart in Germany. The poster is High Performance Computing by and for Patient-Specific Mechanical Properties.
Yeah. The poster highlights our biomechanical research and its software stack. And we demonstrate how a computationally cheap analysis of the input data allows to significantly reduce the energy usage of the simulation or the computation without necessarily losing performance. This is an approach that might work well in other domains too. And yeah, the updated posters outside, and I'm happy to welcome and to discuss that with you. Thank you.
Thank you. Next presenter is Tushar Thakur from EPFL in Switzerland. And the title is High-Throughput Computational Screening of Fast Lithium-Ion Conductors.
Yes, indeed. This is a materials discovery project for solid-state batteries, which have higher energy densities and do not fail catastrophically like their conventional counterparts. Now, to automate and keep track of tens of thousands of calculations involved within this project, which I run at the level of density functional theory, requires a robust framework. And AIDA serves this purpose, and it also keeps track of the provenance, meaning that all my results and data are easily shareable and reliably reproducible. And for any detailed questions, please feel free to come at my poster session. Thank you.
Thank you. Next is Marek Jacob from DWD in Germany, and the title is Icon GPU for Numerical Weather Prediction, a status report. Yeah.
Thank you very much. So I'm responsible at the German Weather Service to prepare our model for GPU computing. And on our poster, we discuss why we are looking into GPUs and how we use Fortran and OpenACC to program the GPUs. We discuss lessons learned from the porting of this actively developed model, and also have a little bit to look on the performance and how that compares to our current vector machine. So if you're interested in Icon and Icon GPU computing, and would like to discuss Icon on GPUs and learn Icon on GPUs, then come to my poster 33. See you there. Thank you.
Thank you. Next is Shivam Barvi from Argonne National Laboratory in the USA, and the title is Interpretable Compression of Fluid Flows Using Graph Neural Networks.
Hi, everyone. So the application scope we're looking at is accelerating CFD solvers using this strategy called database reduced order modeling, where the idea is we take the input and we compress it into a latent space and then advance this latent space in time and then decode it using a decoder. Typically, the limitations in this approach are the projection operators used in the encoding and decoding stages are not compatible with unstructured grids, and they're also resulting in latent spaces that are not interpretable, meaning we can't really physically access what's going on. So we're trying to address both of these issues in sort of one unified architecture based on graph neural networks. So if you're interested in interpretable machine learning for mesh-based simulations, please stop by. Thanks.
Thank you. Our next speaker is Nicola Krieger from ETH Zurich in Switzerland. And the title is Investigating the Mechanism of a Local Windstorm in the Swiss Alps using Large-Eddy Simulations.
We use the model FVM written with the domain-specific language GT4Pi to perform large-eddy simulations. These large-eddy simulations are performed in very steep and complex terrain. With these simulations, we do not only test and validate the formulation of the model, but also try to learn something about the local wind phenomenon in the Swiss Alps. If you want to learn more how we set up these simulations and about the local windstorm, please come and see my poster.
Thank you. Our next speaker, Thomas Spendelhofer. He's from the Tokyo Institute of Technology in Japan, and the title is Iterative Refinement with Hierarchical Low-Rank Preconditioners Using Mixed Precision.
Good morning. So we investigate hierarchical low-rank approximations in the context of iterative refinement for dense matrices arising from the boundary element method. And by taking advantage of the structure of those matrices, we can achieve a factorization at a reduced cost, which we then, similar to mixed precision approaches, can refine to a desired accuracy while still achieving a faster time to solution. And if you're interested in this, I'd be happy to explain more during the poster session.
Thank you. Our next speaker, we have two speakers. We have Michael Stanecker and Ahmed Nabab. They are from the ECMWF in Germany, and the title is Loki version 0.1.1, a source-to-source translation tool for numerical weather prediction codes and more.
Do you want to maintain just a single Fortran source code, but still want your code to be optimized for multiple computing platforms, including emerging HPC trends?
If so, we present Loki, an open source Python-based source-to-source translation tool for Fortran, purpose-built for ECMWF's IFS, but not restricted to it. Encode and create custom source-to-source transformation, generate call graphs, lint your code, and apply powerful interprocedural analysis.
Thank you for listening, and we look forward to discussing Loki further with you this evening.
Thank you. Is there a Thor somewhere?
Sorry?
Is there a Thor? Thank you.
Sadly not.
Our next speaker is Luca Fideli from CEA in France, and the title is Modeling a Novel Laser-Driven Electron Acceleration Scheme, Particle in Cell Simulations at the Exascale.
Yeah, good morning, everyone. So this poster deals with particle in cell simulations of a laser-driven electron accelerator. Essentially, we devised a new strategy to improve the amount of accelerated charge, and we validate it by means of large-scale simulations. And we performed these simulations on several top supercomputers, including Frontier, Fugaku, Summit, and Permut, using our open source code WARPEX, a code that was awarded the Gordon Bell Prize in 2022. And if you are curious, come to see poster 40 later. Thanks.
Thank you. Andreas Jacques from ETH Zurich in Switzerland. The title is MPI for Multi-Core, Multi-Socket, and GPU Architectures, Optimized Shared Memory All Reduce.
Thank you. From CSTS in Lugano. Today's computers have more and more cores per node, and depending on the programming model, also more and more MPI tasks per node. And for this case, we revisited the MPI all-reduce algorithm. This is also relevant for internode communication. For everybody who is interested in MPI all-reduce or similar things, or just interested in the poster, just come to us. Thank you.
Thank you. Our next speaker is Daniel Bauer from the Friedrich Alexander Universität Erlangen in Nuremberg in Germany. And the title is Multigrid in H-curl on Hybrid Tetrahedral Grids.
Yeah, thank you. So I work on implementing a multi-grid solver for Maxwell's equations in HiTech. HiTech, that's short for hybrid tetrahedral grids. It is a finite element framework that wants to combine the flexibility of an unstructured tetrahedral mesh with the performance of uniform refinement. So we're dealing with curvilinear block-structured grids. And we have a strong focus on matrix-free multi-grid algorithms. And with that, we have already demonstrated that we can solve Stokes systems with 10 to the 13 unknowns. Yeah.
Thank you. I'd like to invite Hardik Kothari from Università della Svila Italiana in Switzerland. And the title of the poster is Multi-Level and Domain Decomposition Solution Strategies for Solving Large-Scale Phase Field Fracture Problems.
Thank you. Good morning, everyone. So in this work, we are talking about how to solve large-scale problems, which are specifically arising from phase field fracture problems. In order to solve this problem, we use multi-level and domain decomposition methods. These problems are quite difficult to solve because they are non-convex, non-linear, and we also have to handle inequality constraints. So in order to solve these things, this complicated problem, we use these methods. In this work, we will show how this method outperforms the standard approaches. So if you are interested in methods, problem, or both of them, please pass by, or just want to chit-chat, you can pass by. Thank you.
Thank you. Our next speaker is Judita Runzikova from the Czech Technical University in Prague in the Czech Republic. Numerical simulation of gradual compaction of granular materials and the uncertainty quantification of the proposed mathematical model.
Hi, I would like to invite you to poster 44. The poster deals with gradual compaction of granular materials, for example, sand or gravel. It's also about the algorithm and about the model of hyperplasticity and the uncertainty analysis. Thank you.
Thank you, Judita. Lydia Karos from the Imperial College of London in the UK. The title is Optimization of Non-Conventional Airfoils for Martian Rotorcraft with Direct Numerical Simulations using High-Performance Computing.
Thank you. Hi, everyone. So Martian conditions are very challenging for designing rotorcraft, and they are very different from Earth's conditions. So Earth's helicopter airfoils don't work on Mars, are not efficient. So my work consists on optimizing airfoils for helicopters for Mars using genetic algorithms, and the cost-function evaluations are direct numerical simulations using a high-order, accurate, highly scalable code, which runs on GPUs. Come to my poster if you want to find more. Thank you.
Thank you. Next is Slavko Bador from ECMWF, Germany. The title is Parallel Second-Order Conservative Remapping on the Sphere.
Yes, hello. This work is about MPI parallel first and second order conservative remapping on meshes, on arbitrary meshes on the sphere. We allow data staggering on these meshes, so this means data can be localized in mesh vertices or in mesh cell centers. The whole implementation is done in Atlas library of the European Center and is publicly available. And Willem and I are here today and can answer questions about this. Thank you.
Thank you. Our next speaker, Samuel Cruz from Università della Svizzera Italiana in Switzerland, and the title is Parallel Training of Deep Neural Networks.
Good morning, everyone. So neural networks are becoming larger and larger and harder to train. One way to tackle this problem is through parallelizability. Therefore, we propose two distributed training methods that leverage nonlinear domain decomposition methods, making our methods highly parallelizable. If you have any questions or simply wish to drop by, please come by our poster at P47. Thank you.
Thank you. Two speakers next. Het Mankad and Sanyal Rao from the Carnegie Mellon University in the United States. The title is Proto-X, a first look.
Hello, everyone. So here we ask the question is that how do we help PD library developers to produce a code that can improve their current performance? And a solution that we propose is to add a math-based code generation system as the library backend that understands its semantics. So in this work, Proto-X, Proto is the math library, and Spiral is the code generation backend. Please visit our poster to learn more. Thank you.
Thank you, Ed. Next speaker, Christoph Müller from Metro Swiss in Switzerland, and the title is Simulating Aquaplanet using Icon with a GT4Pi DSL dynamical core.
Yes, good morning. So there was another poster on GT4Pi, which is a Python framework for writing high-performance weather and climate code. And what we did is we used GT4Pi to rewrite the dynamical core, or all the computations in the dynamical core of Icon in Python. And now we can run Icon with all of the computations substituted by the high-performance code that is generated by GT4Pi. And we ran Icon this way, and we also confirmed our results then by running Aquaplanet. And if you're interested in the technical details of this, then come discuss with me at the poster. Thank you.
Our next speaker is Johannes Sava from EPFL in Switzerland. The title is Towards a GPU-enabled linear response algorithm in the Sirius library.
Hello, everyone. So the holy grail of computational material science is the discovery of new materials only by means of simulations, with an accurate description of their properties. Two methods that can provide this information rely on a linear response algorithm, which is a very expensive computational step. To reduce this cost, we implement the linear response algorithm on a library called Sirius, and by coupling this with a very popular code called Quantum Espresso, we can run on both NVIDIA and AM GPUs using the same code. To learn how we did it, please come by my poster and also to see the latest results. Thank you.
Thank you. Stefano Ubbiali is our next speaker from ETH Zurich in Switzerland. Towards a Python-based performance portable finite volume dynamical core for numerical weather prediction.
Thank you. So good morning. So in the context of the past project Kilos, which is involving ETH, CSCS, and ECNWF, we present recent progress in the development of a Python implementation of the FEM dynamical core for numerical weather prediction. The implementation is based on the GT4Pi framework to achieve performance portability. So we show numerical results on an established benchmark and the scalable performance of the model, both on CPU and GPUs, and single and double precision. And finally, we compare the performance of GT4Pi against different flavors of C and Fortran on a cloud microphysics dwarf. So thank you.
Thank you. Our next speaker is Silviano Coletti from Chelonia SA in Switzerland, and the title of the poster is Tunable and Portable Extreme Scale Drug Discovery Platform at Exascale, the Ligate approach.
Hi, I am Daniele Gregori from E4 Computer Engineering, because Silvano is incoming. In Ligate, we aim to integrate and co-design the best class components open source like GROMACS or proprietary intellectual property in Europe like Ligen, developed in a previous European Horizon 2020 project, to keep the worldwide leadership on computer-aided drug design, exploiting the today high-end supercomputing and tomorrow exascale resources available in Europe. Thank you.
Thank you. Our next speaker, Thomas Meyer from University of Zurich in Switzerland. The title is Ultra-High Resolution Simulations of Planetary Collisions.
Hi, everyone. I added an SPH implementation to one of the best gravity codes, PKD-Graph3, targeted at modern hybrid supercomputing architectures like the upcoming ALPS at CSCS. With this code, I simulate collisions between rocky and gassy planets at high resolutions. If you want to learn details about the implementation, how its performance stacks up to its predecessor, and why high-resolution simulations are needed for this application, please visit me at my poster. Thank you.
Thank you. Next speaker, Saurav Deshpande from University of Luxembourg in Luxembourg. And the title is Novel Geometric Deep Learning Surrogate Framework for Nonlinear Finite Element Simulations.
Thanks. Hi, everyone. So this work proposes a graph unit architecture based on 2 deep learning layers. You can see there, the first one extends the concept of multi-channel localized operations in CNNs to arbitrary graph structure inputs. And the second one is the pooling operation, which allows learning on high-dimensional inputs through their reduced representations. So we show the implementation to the surrogate modeling for nonlinear finite element simulations, but the work can be used across various fields. So if you're interested in this, please feel free to drop by my poster, and it's at near the reception. And thanks.
Thank you, Saurav.
Yeah.
Mikhail Kirillin is our next speaker from the University of Bonn in Germany. And the title is the P4EST Software for Parallel AMR, a shared memory workflow.
Hello, everyone. We develop software for adaptive mesh refinement, and it's used in numerical simulations to get higher accuracy in the domain of interest while keeping the lower computational workload. And in this poster today, we are going to present 2 of our latest enhances, namely vectorization with advanced vector extensions, and second is MPI3 shared memory windows. So if you're interested into these low-level software optimizations, please be welcomed into my poster stand. Thank you.
Thank you. Did I go? Okay. So this brings us to the end of our poster lightning round. I look forward to seeing you later today, and let's vote. We have 50 awesome dynamic presenters, so I look forward to that session with you. Thank you.